Assalamualaikum and a very good day everyone. My name is Nurhanisa Zulkifli and these are my group members. The first one is Hanshaida Izati binti Nur Izzat and the second one is Nur Fatin Nadiha binti Azizul. Today we'll be presenting on nutrient media preparation, a fundamental step in fermentation process that support the growth of microorganisms. This preparation not only important in laboratory setting, but how it connects to industrial application and what are benefits on the society.
What is fermentation and how does it work?
Fermentation is a biological process where microorganisms like yeast and bacteria convert organic substance such as sugar into other products like alcohol, acid, and gases. Traditionally, it has been used in food production, for example in the making of tapai, yogurt, and tempeh. Today, fermentation has evolved into a key technology across industries such as food, pharmaceutical, and renewable energy. Today, we will explore essential fermentation technique and technology that support industrial scale process for community well-being and development.
Basic of fermentation.
There are two main types of fermentation commonly used in industry. Alcoholic fermentation involves yeast such as Saccharomyces cerevisiae, which produce ethanol. This process is widely applied in the production of alcoholic beverages and bioethanol fuel. On the other hand, lactic acid fermentation is used in the production of yogurt, kimchi, and probiotic foods. From a biochemical perspective, fermentation takes place under anaerobic condition, which is in the absence of oxygen and result in the generation of energy along with valuable end product. The microorganisms employed in fermentation include yeast, bacteria, and molds, depending on the specific product being targeted.
Technology in fermentation.
Next, I will continue with technology in fermentation. In industry setting, fermentation is carried out in large bioreactor or fermenter equipped with advanced technologies. These modern fermenters are fitted with automatic sensors that monitor and regulate key parameters such as pH, temperature, oxygen concentration, and agitation speed. Technologies such as supervisory control and data acquisition (SCADA) systems or programmable logic controller (PLC) allow for full automation and real-time control of the fermentation process, ensuring precision and consistency at scale. Once fermentation is complete, downstream processing takes place to filter, separate, and purify the final product, whether it's insulin, detergent, enzyme, or antibiotic.
What are benefits to society?
Fermentation offers a wide range of benefits to societies. In the food industry, it leads to the creation of nutritious products that are rich in probiotics and contributing to gut health and overall well-being. In the field of medicine, fermentation is essential for the production of life-saving compounds such as antibiotics, insulin, and vaccines. In the energy sectors, it enables the generation of bioethanol, a renewable and cleaner alternative to fossil fuels. Furthermore, agriculture and food waste can be repurposed as fermentation substrates, helping to reduce environmental waste while generating economic value through sustainable resources use.
Nutrient broth preparation. Before fermentation begins, nutrient media must be prepared. Nutrient broth contains peptone, beef or yeast extract, sodium chloride, and distilled water. All of this is essential for microbial growth.
First, 0.8 gram of nutrient broth was weighed and placed in a 100 ml beaker. Then, distilled water was collected from the distilled water dispenser using a measuring cylinder and poured into a beaker. The nutrient broth powder was then dissolved in the distilled water. The mixture was stirred until fully dissolved. And finally, the prepared solution was transferred into a 250 ml Scott bottle.
Sterilization.
The required glassware such as pipette tips, centrifuge, and flask was covered with aluminum foil or wrap using plastic to prevent contamination. Next, each wrap item was clearly labeled with the group name. Then, slightly loosen the bottle cap. The bottle was placed in an autoclave basket and sterilized at 121 degrees Celsius for about 2 hours. After the cycle, the basket was removed from the autoclave. The cap was tightened and the broth was allowed to cool to room temperature. And finally, the nutrient broth was stored at 4 degrees Celsius until further use.